Hey everybody, in this video we're going to be covering Module 3 from the review packet, the review section in the packet. In the past two videos we covered Modules 1 and Module 2, so in this video I'll be covering the Module 3 questions. So we'll start here with number 24. In each of these questions we'll be using the dimensional analysis method. In number 24, we're being asked about a patient that needs 60 milligrams of medication per their kilogram weight. So it doesn't exactly say that their weight is explicitly being used here, but this type of phrasing refers to, in terms of the patient weight, the kilograms. So for every kilogram that the patient weighs, we're going to give them 60 milligrams of the medication. Then the question is, how many grams must you give the patient that weighs 220 pounds? So a couple more things to highlight here is the word grams, and the patient's weight is given to us in pounds. We also have this other conversion factor right here, 2.2 pounds per kilogram. So before we kind of start with our dimensional analysis process, it's helpful to write out the different steps and conversion factors that you have given to you in the question. The first thing that was given to us was that the patient needs 60 milligrams per 1 kilogram. We also had in the hint that 2.2 pounds is equal to 1 kilogram. Right, so that's these two things that I'd highlighted right there. I kind of removed all the words, and that per is kind of like that equal sign. It doesn't necessarily mean the two things are actually equal in terms of weight or that kind of thing. It just means that they're equated in the situation. They're conversion factors to get from to determine something in our dimensional analysis chart. We need to use these as conversion factors. And it doesn't look like we have any other conversion factors immediately told to us. We just know also that the patient weighs 220 pounds. So as we build our dimensional analysis chart, we're going to be using these conversion factors, and usually we'll start with just a table that looks like this right here, and we may need to add on more as we go. So the nature of this type of a problem when you're doing dimensional analysis is you kind of want to start it and build it as you go. You don't necessarily know all the things at the beginning, but we can try to build it along the way and see if we need to include more information or seek more information to build onto the table. So since we were told that the patient weighs 220 pounds, that's where we will start because the patient's medication amount depends on their weight, right? So we start with the 220 pounds. And as we build our chart, we talked about in class that we always want to build the next column by placing the same unit amount or the unit measurement in the denominator of the next column, right? So if we had pounds up here, we want to have pounds down here at some point. So we do see pounds right here. So I can use this conversion factor right here, 2.2 pounds, and right above it, we're going to put what it's equivalent to, 1 kilogram. So we kind of rewrite this horizontally, but we use it vertically in this column. And then, like I said, we're going to want to build more columns as we go. And now in my next column, I see I have kilograms here, so we're going to repeat that same pattern. And in the bottom of the next column, we want ideally kilograms, and we do see kilogram right there. So we can use this conversion factor right there. 1 kilogram is equal to 60 milligrams of the medication. And so, we would kind of pause right here if this was a question on the exam and think, okay, if I were to finish the question right here and try to determine my solution, where would we arrive? Well, we would need to multiply across on the denominator and the numerator. But as we do that, our units will cancel. If we have one on the top and one on the bottom, the units cancel, right? So the pounds cancel. And we had 1 kilogram on the top and another kilogram down there, so the kilograms will cancel. And we're left with one at the very end, which is milligrams. This would be good if the question said how many milligrams must you give, but it says how many grams must you give. So we're not quite done yet. We need one more conversion here. And we need to think about how do we go from milligrams to grams, right? We're currently at milligrams. We need to go one more step to grams. So um, during module 3, we talked about a few conversion factors that you would need to memorize. For the milli prefix, or in this case, milligrams, that's telling us that in general, 1,000 milligrams is equal to 1 gram. Or to get from milligrams to our base, we need to use this 1,000 value for our milligrams to equate that with 1 gram. So this is our additional conversion factor. You should have this memorized because this isn't going to be on the formula chart. You should have that memorized because sometimes you'll need it for these conversions. So now we'll put 1,000 milligrams down here and 1 gram down there. How do we know to place it like this? Well, it's dependent on what was right here, right? We follow the same pattern. We want these two to ideally cancel and end us up with grams. Right, so I can go ahead and cross off there. So now we can go ahead and multiply straight across the top and the bottom. So when I do that, I got 220 times 1 times 60 times 1. So I can kind of ignore the ones because they're not going to affect our answer. 220 times 60. Right, so there's the numerator, 13,200. And we also need to multiply the denominator, 2.2 times 1,000. 2,200. So you might be thinking, these are some large values. We're not done yet. We need to now divide these two. We need to simplify this fraction, and most of the time it's okay if we get a decimal. So we got 13,200 divided by 2,200. Then we get a value of 6. 6 what though, right? We need to measure it in something. It's our last uncanceled or not canceled out unit, 6 grams. That's how much we need to give this patient, 6 grams of the medication. So there's the process for dimensional analysis there. So just to kind of recap that, we had some conversions from the problem that we had given to us. And then there was also one that we needed to kind of formulate on our own or memorize it to remember that, okay, we need to go one more step and try to convert to grams at the end there. Let's try another one. Here's 25. On number 25, it gives us that there are 1.06 quarts per liter, so that's good information. That's a conversion factor that we'll most likely need. 1.06, I'm just going to write QTS for quarts is equal to 1 liter. How many teaspoons are there in 1 gallon? So it's giving us a couple of other measurements there, teaspoons and gallons. There are 5 milliliters per teaspoon and 4 quarts per gallon. So there's some conversion factors there. 5 milliliters per teaspoon, and then 4 quarts per gallon. So writing those two out, The first one was 5 milliliters per teaspoon, and then we had 4 quarts equals 1 gallon. Right, so we have 3 conversion factors here. Maybe we might need another one that we don't see here, but maybe these might just be the 3 that we need. Either way, um, let's just start building our dimensional analysis chart and see where that kind of takes us as we build it. So if you're not sure where to kind of start, you want to kind of start with your question. How many teaspoons are there in 1 gallon? So think of it as you have 1 gallon. You're trying to figure out how many teaspoons is that. You know that you have 1 gallon, so let's start there. If we start with the gallon, then we know that maybe our next column might need to have a gallon below here. And we see that there's a gallon there, and we can convert it to quarts. 1 gallon goes down here, 4 quarts goes right above it. Now we see we have quarts right here. We can cross off our gallons now if we want to, just so we can kind of focus in on what we need to. If quarts is up here, we need to put quarts down here. We see another quart value here. And we see this time 1.06 quarts, and right above it we'll put 1 liter. So there's that conversion factor that we just used, and we can now cross off quarts and quarts. Don't cross out the number, just the unit. We'll need the numbers later on when we multiply. It's like we need 1 more. We're trying to get to teaspoons, but this time it looks like we don't have liters though. So we need 1 more conversion factor here before we can get to teaspoons. I ideally want to put liters down here. I have milliliters, so we need 1 more. And just like in our notes, we had to memorize a few of these conversions. How do we get from milliliters to liters? This is really similar to milligrams to grams. 1,000 milliliters is equal to 1 liter. That prefix milli tells us we need 1,000 of whatever the milli is measuring to be equal to 1 of the base unit. So this is an additional one that you should memorize, that particular conversion. It's really the same thing that I had mentioned up here in number 24. So now we have liters right here, so we can use that in our chart. 1 liter is equal to 1,000 milliliters. That's good. We can cross off our liters. And now we need to convert our milliliters. And we do see milliliters right there. So this kind of works out because we needed that one right there. So 5 milliliters, and we arrive at our teaspoons here at the end, and that's what we wanted. So we can cross off milliliters, milliliters. And now we just multiply straight across the top and the bottom. So I trust that you can, multiply those numbers in the calculator, but when you do, you should end up, I won't show it here, but you should end up with 4,000 over, you get a decimal down here, 5.3. And when we divide those, you'll get a decimal 754.7. Now, teaspoons aren't always measured in decimals, so depending on the question, you'll most likely see rounded to a whole number. For if it's a particular measurement that measures in whole numbers, it'll most likely round the answer to a whole number. Let's look at 26 now. 26 says that there are 3.785 liters in a gallon. That's going to look like 3.785 equals 1 gallon. How many liters are there in 4 gallons? So let's just start with this one conversion factor and see where it takes us. Our question is asking us about something with 4 gallons. And we notice that we have this conversion factor. It also has gallons in it, so that's good. We want these to match because in our next denominator, we want to put gallons. 1 gallon equals 3.785 liters. I forgot to write liters in there. And so we can mark that conversion factor out. And it doesn't look like we need anything else because the question asked us about liters. How many liters are there in the 4 gallons? So this one is just a quick one-step conversion. All right, so we multiply across the top, and in this case, we don't really need to do anything across the bottom. There's just a 1. So when you multiply across the top here, you're going to end up getting 15.14, and we're ending up with liters because that's the unit we didn't cancel. And you could put divided by 1, but you don't necessarily need to. This is our answer right here. '27. We have that an adult weighs 231 pounds. What is their weight in kilograms? And we look at that hint, 2.2 pounds equals 1 kilogram. Most likely we're just going to need one conversion here because it's talking about going from pounds to kilograms. So we start with the current patient's weight, 231 pounds. We follow that pattern down here, we want pounds, so it looks like 2.2 pounds is equal to 1 kilogram, and that's what we want. We want kilograms at the end, so this is just another one-step problem. Cancel, cancel. Now when we do this, you're going to multiply across the top, and across the bottom there's nothing else to multiply, so we'll just be doing 231 times 1, which is 231, divided by 2.2. And then when we simplify that fraction, 231 divided by 2.2, we get 105. So our answer here is 105 kilograms. 28, we've got 1 milliliter of water has a mass of 1 gram. 1 milliliter equals 1 gram. What's the mass of 4 liters of water? So we've kind of gotten the hang of this from the past few questions that, okay, we have milliliters and liters in the same problem. So most likely we'll need to use this conversion factor as well. 1,000 milliliters equals 1 liter. Where did I see that? I saw that by seeing the milliliters and the liters in the same problem. We start to build our formula or our dimensional analysis chart with 4 liters. Mass is measured in grams. So in our next column, we want liters to be in the denominator. Right, so we can look over here and we see there's liters right there in one of the conversion factors, right? So 1 liter is equal to 1,000 milliliters. That's good. We can cancel the liters now. But we need to get to mass, which is in grams, right? So I can see that we have another conversion factor right here. There it is. We just used it. So we can eliminate our milliliters here as well. So multiplying across the top and the bottom here, we end up getting 4,000 over 1, or that's just 4,000, and in this case, grams, because we didn't cancel our grams there at the very last step. We leave that because that's what we want, mass, grams. 29, medication contains 3 grams of that medication per milliliter. So this right here tells us that 3 grams of the medication is in 1 milliliter. This is most likely a liquid medication, but oftentimes these liquids have other things mixed in there too that comprise of that medicine. It might be water, it might be saline, something else like that, right? The 3 grams is just purely the actual medication element itself, right? So that's why we say 3 grams per 1 milliliter of the liquid. What's the mass of 50 milliliters of this medication? So we don't see any of the conversion factors yet. Let's start with 50 milliliters of the medication, which which was given to us in the question. And we can directly see that we have milliliters right there. 1 milliliter of the medication is 3 grams. 1 milliliter of the solution is 3 grams of the medication. Mass is always in grams, so we're good there. We can multiply across the top, and then at the bottom we have a 1. So this will end up being 150 over 1, or 150. And crossing out our canceled out units, we're just left with grams there, 150 grams. And here's the last one. Patient weighs 220 pounds. They require 300 milligrams per kilogram. This slash means per kilogram. This is another weight one, just like the beginning problem that we had. So we'll write out 300 milligrams is equivalent to 1 kilogram of the patient's weight. It tells us that it's available in a suspension of 3 grams per milliliter. 3 grams per milliliter. How many teaspoons should be administered? And it gives us a hint there that 5 milliliters is 1 teaspoon. 5 milliliters is 1 teaspoon. So let's start building this chart. Whenever it's a weight question, medication dependent on the weight, let's usually just start with the patient's weight. And right off the bat, we don't see pounds anywhere in here. Well, that's because we're supposed to use our very common conversion that 2.2 pounds is equal to 1 kilogram, just like we saw in the previous few questions. This is a very common one, probably one you should memorize. So now we know in our chart that we can put 2.2 pounds down here and 1 kilogram up here. So we can start to cross off things as we go. And then in our next step, we ideally want kilograms to go down there. So we look up here, we see kilograms, there it is, right? 1 kilogram, that's equivalent to 300 milligrams. We can mark out those, and we used up that conversion right there. We need to keep building onto the chart. I have a couple more conversions to do. Looks like we don't have milligrams anywhere. We do have grams though. So we do need another memorized factor. We need that 1,000 milligrams to 1 gram conversion. Another one to memorize. Eventually, as you practice these questions more often, you'll realize that these ones show up most often, so you'll naturally memorize them. We're going to put 1,000 milligrams over or below 1 gram. We can mark out our milligrams. We can mark out this one. Right, let's keep building. Our goal is to get to teaspoons because the question said how many teaspoons. So we're still a couple of steps away. Right, looking back at our conversion factors, there's grams. We can take 3 grams down here and 1 milliliter above it. And then yes, we see there's milliliters in that last one. That's what we want. 5 milliliters goes down here and 1 teaspoon goes up here. So we got a lot of conversions going on, but the pattern follows grams, grams, milliliters, milliliters, and we are left with a teaspoon at the end. But notice how your pattern kind of flows as you go throughout this. Multiply across the top and the bottom here. When you do that, you should end up across the top with 66,000, and then across the bottom, you should end up with 33,000 when you multiply those out. So just double checking your calculator that you're able to get that when you multiply across the top and the bottom. Verify that you get these two, and then divide those two, and we end up getting a value of 2. 2 teaspoons is what the patient needs. All right. So it looks like that's the last one. Feel free to go back, rewind through, rewatch anything. As you're practicing and studying for the midterm exam, just remember that in addition to watching these questions, you also want to practice them without looking at your notes or without looking at the solution. If you can do the questions without looking at your notes or solutions, then you should be in good shape for the exam. You want to practice these until you're able to answer them without any support. That's how you know you're ready for the exam. If you have any questions as you're reviewing, feel free to send me an email. Let me know what question that you have, and I'm happy to support you.